Welcome to this Social Computing for Business mini lecture. It's a recording that's been made of just the lecture part and not the videos. The subject is cognitive computing, and I will speak in the second bit about the assignment 2 for the second half of the year. So in this lecture, I'm going to talk about helping humans achieve more and the influence of AI, artificial intelligence, etc. We're going to look a little bit about machine learning and anomaly detection. What is anomaly detection? What is an anomaly? Modelling how commercial airliners descend. We'll look at machine learning and cognitive auditing in accounting, and possible artificial intelligence use cases, and barriers to adoption. And then we're going to look at AI, machine learning, some of the opportunities that exist. There are some references that you can look up for further reading on AI in auditing, and some use cases and barriers to adoption. And then the items in red there, the videos, the future of AI and IBM Watson, etc., those are available on Moodle by separate links, or you can run the presentation in presentation mode and click on the links. Either will take you to the relevant video. But I'm not going to record the video in this recording. So let's look at machine learning and anomaly detection. So if we're thinking about data analytics, according to accountants, they basically had the Future of Audit event in 2016, and they were asked to share what they thought data analytics was, and the main responses are tabulated here. So it's forward thinking, it's visual, it's data visualization, it's insight. The most important one, the most interesting one, is the one highlighted in red. Gaining an understanding of trends, anomalies and variances in data. So data has got all these hidden patterns in it, or quite often has, and so we can look and see, what could we do to make use of those patterns. We're going to be basically optimizing behavior in an imperfect world, so we want to find out how we can sense, detect and act when discovering data anomalies, to reduce waste, discover fraud and promote effectively normality in business and finance. That's our goal. So the university has a Centre of Intelligent Data Solutions with some fairly diverse capability in artificial intelligence, and its staff has a background in mathematics and machine learning and to a certain extent artificial intelligence, and they specialise in commercial and looking at machines and finding out anomalies there, and then being able to detect what's happening and what they can do about it, and mostly in process driven areas, so things which involve some kind of industrial process. Their other title is the Institute for Industrial Research, IIR. They've got 10 years of experience looking at this. They have built up loads of data sets, and you can actually train normal data sets to learn what is a normal kind of set of events which normally happens, so that you can then model what are abnormal events, anomalies that happen outside of what would normally happen. So we want to sense, what do we need to know about? We need to find out what we don't know. When it happens, when does it happen? And then decide what to do about it. Those are the kind of things that we're looking at. So if we think about machine learning defined, the ability to train an algorithm or algorithms to identify some behavior using a known data set so that it can make predictions on an unseen data set. That's what we're looking for. And this use of machine learning is called pattern recognition, sometimes called pattern recognition. Machine learning is used to automatically detect unknown patterns in big data. So accounting may employ machine learning to help turbocharge the profession by, for example, having payments and invoices matched automatically without a human being involved. It's quite easy to read a document and condition the data into the same set of fields and then have it match incoming payment information. Accountants make decisions, they provide confidence and manage risks, and the artificial intelligence machine learning side of things will help them to do this better by freeing up their time through automating and augmenting the more mundane tasks. So what is a novelty or anomaly, and how do we detect them? Well, in this case, learning from just one class of data, e.g. healthy samples, what's called normal samples or typical samples. So we build a model to understand the range of normality. It's usually a statistical model of some sort. Anything outside of this range, so in other words, outside that blue oval area there, most of the data points are inside it, and we can measure the distance from this normal surface, this outside of a 3D oval shape. That's what's called the optimum hypersphere. And then any of those data points that are well outside that sphere, such as the stars shown in blue there, are abnormal data, whereas the ones in white, they're near enough to the surface to be taken as normal or healthy data. The larger the magnitude away from the normal surface, the optimum hypersphere, the more abnormal the data. So let's look at a practical example. We can model how commercial airliners descend, and actually every airliner comes with an operating handbook which tells the pilot how the aircraft should be landed, at what point it should be at 10,000 feet, at what point it should be at 6,000 feet, its rate of descent, a whole series of operating parameters that effectively define a normal descent. So we want to model the flying style of pilots to see whether they're actually doing their landings in the kind of mode that a standard operating procedure would say was a correct landing. Now, in addition to that, airliners, it's a legal requirement for airlines to collect flight data and check their aircraft are flying safely according to procedure. So there's a certain amount of interest in finding out people's landing behaviour. The current method, you can set thresholds at various different heights and just compare where the aircraft is with what it actually where it should be, according to the standard operating procedures. So we analyse the descent by building models at key heights in the descent, particularly where procedures offer performance guidance, and then choose the features appropriate to each height to best represent what the aircraft should be doing at that height. As this is a kind of schematic of the model, so you analyse the individual heights and build 24 height specific training sets. So we can see there's one at ground level, one at 25 feet, 50 feet, up to 10,000 feet. And we, in those models, we define classifiers so that we can actually classify the data, and that leads us to have these training data sets, which we can find out what are the normal, where the aircraft were in a normal range and which ones were in the abnormal range. And then there's a second classifying system, which then which will analyse the whole descent as opposed to what's happening at individual heights, and then that gives a ranked output as to whether the aircraft was landing according to procedure or not. So in this diagram on the left, you can see there is a red line there, and every time that the aircraft, the line representing the aircraft, dips below the horizontal line, 0, it's actually either descending too quickly, or it's too high, or a whole series of abnormality elements there. When it goes above the line, then it's back into the normal range where it was descending correctly. And you can see in this particular diagram, at a height of about let's see, 2,935 feet. That was where it was crossing, where before that it was actually having too high a rate of descent. It was descending too quickly. And also, just in the last 75 feet, there was too high a speed on approach. It had actually dipped down below the, in the region of about 286 feet. If you look at the diagram, it's very difficult to tell from this, but there was a too fast rate of descent during that period, up to about 75 feet. And we obviously want the plane to come down at exactly the right speed, defined in the operating manual, because anything other than that, we're reducing the life of the aircraft by stressing parts, and never mind any kind of like safety concerns that there might be. So the new methods revealed unknown anomalies, and although in this case, this particular descent, the aircraft landed comfortably, it had to recover from a very steep descent. And that was because at the 10,000 feet mark, it was well inside the outer marker of the airfield, and it should have been lower at that point. And so that's the reason. So we can use F-scores to kind of look at various parameters. So we have the flaps. Was the flaps down too far, or were they at the right setting? Was the landing gear deployed? Was the difference between the airspeed and the reference landing speed too high? And was the pitch of the aircraft incorrectly set, so that it was actually tipped up, so it wasn't descending fast enough, or it was descending too quickly? And the larger the F-score in this table of F-scores, the more likely that the parameter will be useful in separating out positive from negative samples. In other words, things that were outside of the normal operating envelope. And we can see that for flaps, this aircraft here, when it landed, has a fairly large F-score, and that means that the flaps were actually too far down. That would have caused the aircraft to come down too quickly. And in the case of the landing gear, the landing gear was deployed perhaps too early, and that caused the aircraft to descend faster than it should have done. And then on the right hand side, you can see that the airspeed was too high, possibly because the flaps were down too far and the wheels came down too early, and also the pitch of the aircraft was much too high. It was actually tipped down too much, so it made a very rapid rate of descent. And that can stress the aircraft, it can raise fatigue in metal, so something to be avoided if possible. So this new method flagged up 3 times more anomalies than the current industry standard method, which I haven't defined here, but and it not only revealed what caused these anomalies, such as the flaps being too far down, but also its location during the descent, so you can actually see at what point this thing happened. And the reason why these things happened was that the aircraft was poorly set up for a landing. The pilot hadn't really thought about where it was, but it led to also a bumpier than usual landing because it came down very quickly. The pilot didn't really have enough time to kind of zoom it out, had to get it down the runway. If it's coming down quickly, it'll end up going across the ground faster, so there's the danger of it actually going off the end of the runway. Now you can compare looking at aircraft. So for example, flight safety, descent, landing procedure can be modelled. We can estimate normality, we can give it a normality score, and then we can report to, for example, in the case of aircraft, the airlines to say that some planes are actually being landed badly, and that they can monitor that and maybe do more training to avoid accidents. In audit testing, one of the things that we can use normality for is to find out whether we can actually automate something. So if certain parameters are outside the normal area, we can have the auditing know that they've got the system address that with some kind of automated system. So we can look at key parts of the audit process or assess it as a whole. So let's have a look at that. So the big four firms, which you've got KPMG, Deloitte, Ernst & Young, and the other one, which I've forgotten, are investing in research and development in using artificial intelligence, and KPMG have done some work with IBM Watson to automate auditing functions. So that's a fairly easy use of machine learning, actually. Deloitte developed a tool called Argus that can automatically scan documents for key accounting information. And some of this is still in its early stages, but they are working on it, and will make progress. This is KPMG's artificial intelligence software, and it can do things like predictive analytics. So it can look at what's going to happen before it actually happens by using some AI techniques. And it's got various other elements. So many of KPMG's audit, tax, advisory and other professional services rely heavily on judgment-driven processes. Adding cognitive technologies, massive data analysis and innovative learning capabilities to these activities has the potential to advance traditional views on how talent, time, capital and other resources are deployed. So you can actually have, when you're taking on somebody, human beings tend to kind of use their bias and maybe bias even the words and use gender stereotypes to assess the capability of candidates, whereas a machine doesn't do that. And so quite a lot of interviews for professional services firms now include a check of the of an interview candidate's background, which takes out all the human biases that there might be in there. Deloitte developed this tool Argus. It can scan documents. They're using Argus to upload multiple document formats, and with the idea that you can also identify risks in the data, trends and anomalies, visualize the results and compare documents against base templates to identify variations. They also developed a tool called Optics, which is a big data in-memory tool. It applies analytical techniques to large data sets to uncover trends, patterns, anomalies, etc. With the idea of working out what they are and making some predictions about what should be done. So some possible AI use cases and barriers to adoption. Well, again, going back to that conference, the number one skill that all companies seem to be looking for is knowledge of data extraction tools and the mining of business intelligence. So at level 6 in a business intelligence unit, we do teach some of those techniques. So just bear that in mind if you want to get involved with that. There's quite a lot of work involved in doing it, but you will have some skills when you leave if you went down that road. So what we don't want to do is to replace the intelligence of people, but we do want to replace the propensity to mistakes that people have. So we can use novelty anomaly detection methods to assist with things like checking whether a company is profitable or not, doing the kind of assessment of profitability. You can do that automatically from just by matching and manipulating figures. At a lower level audit testing, we can do things like automating the matching of documents such as purchase orders, invoices, goods received notes and cash payments. And then common audit activities shown in blue there: planning and costing the audit, assessing high-level risk issues, discussions with management and receiving their assurances. These are all things that a human would still do. So some challenges to adoption. Firstly, if you want to use machine learning, artificial intelligence on data, you actually have to get hold of the data. So In some companies, you've got to persuade your client to let you have the data for analysis. So that's one challenge. Legacy software, sometimes you need to get the software updated before you can. It's in a state where you can actually use it for automatic detection of systems, etc. for fraud. Employee education, staff will require training in the new technology to know what its limitations are in principle, and regulators will want to know what you're doing with data and when you're going to use it for, and when you're going to get rid of it. All that is part of the General Data Protection Regulation, or GDPR, which is coming in order to replace Data Protection Act. So there are various practitioner view on challenges. These are a conference. These people were asked at the Institute of Chartered Accountants in England and Wales. They were asked what are the big challenges to this, and one was cost, one was having the skills to do the analysis, one was having the IT systems to do it, persuading clients that they would go along with it, the impact of standards and regulation. With not much thought about competition at that stage. And on the right hand side you can see the opportunities: better client services, better insight on the auditing, better audit quality, efficiency and cost savings improved, competitiveness improved, risk management and fraud detection improved. So let's look at some opportunities. There are some strong opportunities to apply machine learning in largely numeric process-driven fields. Now that we've got cheap processing power and storage units and in-memory databases like SAP HANA, you can get these algorithms to execute in minutes rather than hours or days. And that then leads you to be able to do pattern matching and the data extraction manipulation, and looking at for things like fraud and just general changes in patterns that would indicate something was going on that you want to pick up. The other thing is that these technologies can be possessed by smaller companies than the big four, and therefore that gives them something of an advantage, a level playing field in trying to compete with the bigger companies. Now, Ernst & Young, this is a tablet application, and it's actually looking at the profitability of a particular product category, and that it actually uses machine learning to generate this information from accounts. So it can pick up the information from accounts and it just gives you a profitability analysis which is independent of somebody who might be looking to manipulate the accounts. So there's some resources for further reading. List of resources are shown here, so by all means follow those up. Edward Smart and David Brown were the two principal people who did a bit of work at Portsmouth on the aircraft descents and anomaly detection in aircraft flight data. This is a little description of how that works in a bit more detail, and a link to their website. So then the next part of the lecture is to look at the future of AI and IBM Watson, and this is where the videos start. So you've got a video on how Watson works, and then this is a more interesting one which shows how IBM actually understands answers the right answer in a particular context. So that's a very useful and interesting video to have a look at. This one looks at AlphaGo, the Google DeepMind. DeepMind was a British company which was bought for, I think it was $500 million by Google, and it now became Google DeepMind, and it's an algorithm which can teach itself. It can learn in a kind of more human-like way. So watch the video there on how that managed to beat human players of the strategy game AlphaGo. And then lastly, there's a video showing what might happen if Google DeepMind was given its head. It's the kind of thing that Elon Musk and Stephen Hawking have warned we must be careful of putting too much faith in AI systems. So it just gives you an alternative perspective to be aware of in thinking about how we should let AI continue. So that's the lecture for this, and so watch the videos, and I will talk in a minute. I'm just going to put this recording on hold, so you'll see the screen go blank for a sec. Hi again, so we're back, but I've now removed the lecture, and I've put up the question paper for assignment 2, the new virtual community. You can get to this from Moodle, from the assignment link, or in the same section that the assignment link is. At the moment it's highlighted on the social computing Moodle site. So you can work in groups of 3 or 4 to identify a new community area for virtual community. So identify the focus area, carry out preliminary market analysis to find out whether it's a viable community, design the community. You can use any design tool you wish. It could be PowerPoint, it could be Visio, it could be whatever you want to use. So explain how it works. We're not going to be marking the tool you use, just the results. A description of the community designs should be illustrated by a fairly good number of images. Certainly you should show every single possible use of an app, for example. If you choose to make an app or PC application. Your community may be accessible via a PC or mobile interface. Create a business model to fund your new community and model it on a business model canvas, and in other ways. You've basically got to use all the constructs for analysing the community that you used in assignment 1, but for assignment 2. But in addition to that, we want a business model canvas if you didn't do one before, SWOT analysis and a PESTLG analysis, so political, economic, social, technological, legal and global analysis. You should collaborate together and hold meetings, at least 3 meetings, and include in the appendix the 3 sets of meeting minutes with who said what on it and who was in attendance. The submission deadline is Friday the 20th of April 2018. Submit online to Moodle. Any words involved, there's a 3,000 word rough word limit. I probably won't count them. That doesn't include the bibliography either. And try to reference everything in APA format. That's what you should do, and make sure it's in alphabetical order as well. And the work should be submitted as a PDF. So make sure you send it as a PDF, and make sure in the file name you have put all your student numbers, so that I know who was associated with the work. Make sure that happens, otherwise you may find you don't get any marks. And I think that's really it. So you can check the work through Turnitin. But as I say, the submission deadline Friday 20th of April 2018. So you've got a reasonable amount of time to do it. So get working in groups, define your community, design whatever app or PC element you're going to do. I've talked about that in the classes, so and in previous lectures. So with that, good luck with the assignment, and I wish you a good day. Thanks.